So now we will see what is a successor and predecessor. So what is a successor? Okay, what is a successor? Who are coming after me is called as successor. Am I right? So who are coming after me is called as a successor. For example, who are coming at the back of me is called as a predecessor. Okay, who are present in front is called as successor. Who are present at the back is called as a predecessor. So same, you just take it over here. So successor means after. Okay, so predecessor means before the node and after the node. So for successor, what is the successor of D? After D, what are the elements that is being present? See H and I. So answer is H and I for D. So now successor of B, what will be the element? D and E are the successors, right? Then for successor of C, what are all the what are all the elements that is being coming after C? It is F and G. Okay, so like this only you must have to tell. Then what is called as a predecessor? So before the node. So for B, what is the predecessor? A is my predecessor. For C, what is the predecessor? A is my predecessor. For D, B I can tell. Okay. Then for E, B I can tell. Can you understand? So like this, you must have to calculate the successor of the node A and the predecessor of the any node that they are asking you in the question. Okay friends, so now we will go for another very important point which we are going to start now is height and depth calculation. Okay, this is a very important heading. So we are going to discuss about height and depth. So level we already discussed. So they may ask in comparative examinations whether as a problem or they may ask you as a points, like this they may ask you. Okay, so now we will go for the discussion. So what is the height? Okay, so if they are asking you to find the height of a node, please see the downward direction. Okay, so if they ask you to find the depth of the node, from that node you see up. Okay, total number of nodes that is being present in the upward direction. So look up from a node is called as depth. Look up. Okay, look down is called as your height. So based on this, let me find the height of, for example, B. Okay, and let me find the height of N. Right? So now you tell me, I want to find the height of B. So where is B? B is here. So look down from the given node. So this is the node being given. Look down. How many number of nodes? Maximum number of edges that is being present in downward direction is called as the height. So from B you see this is also present. So this is also present, and see like this also it is present. So we must have to take the maximum edge. Okay friends, so maximum edge among all these connections is called as height of B. So 1, 2 and 3. So height is 3. So that is B to D, then D to I and I to N. B to D, D to I to N. So you should have to take the maximum connectivity line. So here for B it is 3, right? So now you say for N. So N is this node. Okay. So what is the height of the node? See downward from N. Any other node is present. Nothing is present. So height of N will be 0. Right? No connectivity is present. So we are putting it as 0. So now you find for A. From A, you just see downward. What is the maximum edges that is being present? For that also you see, this is going to be your maximum edge, isn't it? So 1, 2, 3, 4. So for A, you will be having the maximum edge as 4. Do you feel easy? Keep this as your trick for finding it. Next you find depth. For depth, you should have to see in the upward direction. So now you find the depth of, for example, F. Find the depth of the node F and depth of the node A, right? And depth of the node N. For this also you should have to take only the maximum number of connections that is being present. So for F, here it is. Okay. So see upward direction. Okay. So F, C and A. isn't it? So this is the nodes that is being present in the upward direction. So maximum connectivity is 2, isn't it? Now for A, okay, for A you find, see upward from direction from A. Is there any node present? Because this is your root node. Okay, so there is no edges emerging from here. So your value will be 0. Next for N you see maximum edges that is being present in the upward direction. So 1, 2, 3, 4 and 5. See 1, 2, 3, 4, isn't it? 1, 2, 3 and 4. So maximum number of edges is for N it is 4. Can you understand? So like this only you must have to calculate, very important point. Okay, so make a note, right? These are all some of the important points and formulas. So you must have to remember. Sometimes they may ask you in comparative examination, okay, based on the tree data structure. So the depth of a tree is always equal to that of height or the level of a tree. So like this they may give you the reasonable statements and they will ask you to find whether it is true or false. So here this is the true statement. So the depth of a tree, okay, so the depth of the tree if we calculate, it will be equivalent to that of the height of the tree or the level of a tree. Okay, because in both we are considering only the maximum edges. So for example, if I find the depth of a tree, it will be 4. If I find the height of the tree, 1, 2, 3 and 4. So depth is also coming as 4 and for height of node also it is going to come as 4. For level you see 0, 1, 2, 3 and 4. Can you understand? 0, 1, 2, 3 and 4. So here we are considering the root nodes. Okay, for height and level we are considering the edges. So both we are getting the same answer. See, what is the depth of a tree? So from here only I should have to find. This is the maximum number of edges. So 1, 2, 3 and 4, isn't it? Now height of a tree. So from the root node I must have to see it down. So 1, 2, 3 and 4. Okay. So now what is the level of a tree? By the stages only we will be calculating. So 0, 1, 2, 3 and 4. So for all you are getting an answer as 4, 4 and 4. That's it. So next you see, next point. In ith level, all the elements are of same depth. In any level if you just go, all the depth, if I just calculate the depth by going to any level, it will be of same depth, right? So for example, I am here in this location. Okay, I am going to find the in ith level, this is in the second level, I am in the second level. If I calculate the depth for all the elements, what will be the depth for D? 1, because see the upward directions 1, 2. For E also 1, 2. For F also, G also 1 and 2. So this point is true. Suppose instead of depth, if they give as height, is this true or false? You just find and tell me. So for height, I must have to see it down, isn't it? For any particular node, we are not getting the same height. For D, this is the maximum height. For E, if I take, this is the height. So we are having differentiation in height value for all these nodes, isn't it? So for this, it will be false. Next. This is a very important formula. So this formula is applicable only for binary tree calculation. So this is the formula. So number of nodes in any level I. Okay, it is 2 power I. Okay, so this value you should have to take if by default if it is given as 0. Okay, if a level of a tree we are taking it as 0, this is the formula. For example, from 1, 2, 3, 4, like this if I consider, you should have to take the formula as 2 power I minus 1. Okay, please make a note of it. If you are taking by default as level 0, apply this formula. If we take level starting as 1, you take this formula. So now total number of nodes in level 2. For example, I want to find for level 2. What will be the formula? So it is 2 power 2. So answer is equal to 4. Okay. So find. This is my level 2. What will be the answer? 1, 2, 3, 4. See, I have got the answer. Total number of nodes in level 2 is 1, 2, 3 and 4. So what is the total number of nodes for the same tree if level starts from 1, 2, 3 and 4. So here for level 2, so what will be the answer? So 2 power 2 minus 1 is going to be 1. You are getting the answer as 2. So total number of elements in level 2. So this will be 1, 2, isn't it? So in this level 2 I have 2 elements. See, I have got the answer, friends. So like this only you must have to calculate to find the total number of nodes in any of the given level. Okay friends, so next we are going to see about path. So this is also a very important point. So what is a path? So path tells you what is the sequence of nodes that is being connected between the given two ends of a node. Okay, for example, what is the path that is being lying between A to H? Okay, so what is the path that is being lying between A to H? See, A to B, isn't it? So A to B, then B to D, sorry, so B to D, isn't it? So B to D, then H. Can you understand? So this is the path that is being present between A to H. So the total number of nodes present are 1, 2, 3 and 4. So the path value is 4. So in this we have internal path and external path. Okay, so what is called internal path? The nodes that is being lying between the source and the destination is called as your internal path, right? So what is an external path? These two are called as your external path. Okay friends, so in this session we have discussed all the possible types of tree terminologies which seems to be very important, right? So in the next session we are going to start up with some of the important questions that may arise related to the top nodes. Okay friends, so bye.